Hey everyone! We've been looking at mirrors and how images are formed using the ray diagrams. But what if we need exact numbers? The ray diagrams sometimes give approximate answers, and they really depend on how precise you are. So in this video, we're going to look at different equations that we can use relating to mirrors that will help us find those images and the properties of those images. The first one is magnification. We want to know how big an image is. We can tell from a ray diagram how big it is, but there's the image right here. What about an equation? So it turns out that by drawing these rays, that there's a lot of geometry here, but you've got similar triangles being formed, and there's actually a relationship between the object height, the image height, the object distance, and the image distance, because they're similar triangles. And it turns out that the magnification, which is, right, how big is your image compared to your object, the image height divided by the object height, is equal to negative q over p. So negative the distance of the image over the distance of the object. Again, that just comes from the geometry. So we need to understand what the values for magnification are. So again, the magnification is comparing the image height to the object height. So if your image is bigger than your object, then this number is going to be greater than 1. So greater than 1, larger than the object. If the magnification is equal to 1, that means that the image height and the object height are the same. So then the image is the same size as the object. If the image is smaller than the object, let's say that the image is one half of the object height, then you can see that the magnification will be 1/2. It's going to be a number between 0 and 1. And finally, what about if the magnification is less than 0? If the magnification is negative, all that means is that the image is inverted. We saw some ray diagrams where the object was upright, and then once the image was formed, the image was somewhere over here, inverted. So when you do the calculations using the magnification equation, if it's a negative number, that tells you that your image is inverted. The only other equation that we're going to use is the mirror equation. So it relates the object distance p, the image distance q, and the focal point. And it turns out, once again, that this equation comes from looking at geometry and using those triangles to get that information. It's too much for this class. We're just going to accept the result that this is how those three quantities are related. So as long as you know 2 out of the 3, you can find a third one. If you know the focal length of your mirror and you know where you put your object, you can solve for q and see exactly where that image is. When using this equation, you must pay attention to the sign conventions. So what I mean by that is in the following slide, you need to know if p is positive or negative, and q and f. So this is a nice visual here. It shows that this is the front or the real side of the mirror. So the object is on the left side here. The light is always coming from the left side. So the reflective surface is right here where the light is reflecting. So if your object is in front of the mirror, which we will never do a problem where it's in the back, so that means that p, the object distance, will always be a positive number. If the image formed is in front of the mirror, and this happens when you have that real image where those rays intersect, then that means that the image distance is also positive. However, we've seen that sometimes the image was formed over here. Sometimes for a flat mirror, the image was always on the back, right? Because the rays, when they reflected, and you had to trace them back and form your image over here somewhere. So that means that if the image is formed behind the mirror or in the back of the mirror, that q is negative. So that is the sign conventions with p and q. And this works whether your mirror is flat, convex, or concave. Object and image in the front is positive, object and or image in the back of the mirror is negative. And then the only other sign conventions are for the focal length. If the focal length is in front of the mirror, that's positive. If it's in the back, that's negative. So we talked about the concave mirrors, and those had the focal length in front of it, so that would be positive for concave. However, we talked about the convex mirrors that had the focal point behind them, so that means that the focal length is going to be negative for the convex mirrors. So you've got to make those numbers positive or negative, even if they don't tell you that it's positive or negative, just based on what the problem says. Is it a concave mirror or is it a convex mirror? And then the only other sign convention, which we already mentioned, is that a negative magnification means that your image is inverted. Likewise, if the height of your image is negative, that also means that it's going to be inverted.